Hello everyone, in this video we are going to study about LSM trees. LSM trees stand for log structured merge trees. Let's see why we use LSM trees. Okay, so first of all, for that we need to understand what's the problem with B trees in that case. So B trees are pretty great, but B trees is going to take read all of log n time when we are going to read the data, and the writing, it is again going to take O log n time. That's the major problem. So first problem is problem of speed. That log n time at the write heavy system is going to be like, let's say, a lot of time. So now we need a write heavy system. B trees are working great when there is a read heavy system, but now we need a write heavy system. So log n time is going to create a lot of problem. So the first problem is problem of speed. Second problem is in the B trees is going to put the data in the random places in our disk. This is known as random places writing. So let's say our first block is here. After that, we figure it out that my next block is here. Then my pen will move there, my disk will rotate, and I will reach to this point. Then let's say my next point is here. Okay, and then I finally get the data. So my disk has to rotate a lot. And secondly, I have to, like, say, jump to the different tracks, different sectors, and this is known as random place writing. That is also creating a problem. So to solve this problem in a write heavy system, we want to create a write heavy system. So we have to go to LSM trees. That is usually used in NoSQL, Cassandra, RocksDB, and let's see how we can do it. So the solution is pretty simple. We have discussed about write ahead logging. So how our writing works in our database. First of all, I just make you just revise it one more time. First of all, we write the data in RAM. Then we write the data in OS cache. Then we write the data directly in our disk cache. And then we finally write the data in our disk. This is how the whole complete writing happen whenever there is an insert query or an update query in our database. Now what we are going to do, whenever we are going to make a write query, first of all, we are going to write it into our memtable. That is our RAM. Okay. At the same time, okay, we are going to insert into our write ahead logging. We have discussed this thing, what is write ahead logging in our last video. We are going to directly write into our write ahead logging file with the help of direct IO. We've discussed this point that for our durability, we are going to write it in this particular location. Whatever this, and we are going to store the data in our memtable. That is a red black tree. After that, what will happen whenever our memtable, or you can say our red black tree, is going to be filled, or let's say our RAM is going to fill, we are going to put this data in our SSTable. These SSTable are going to maintain some segments. Okay, in segments in our sorted order. Okay, so sorting is very necessary. Why sorting is necessary? For our range queries. Okay, so we have to maintain our sorting. We don't want to lose the feature of the B tree of the reading. Okay, we still need our log n searching time. Okay, so we have to maintain the sorting as well. We maintain the sorting. So let's say if we insert something, okay, if someone wants to read that thing, it can directly get the data from the memtable, or you can say directly retrieve the data from the RAM. Okay, that will give us O1 speed. Okay, and whenever we are inserting something, we are first of all inserting in our memtable, so we have that data. Okay, and let's say it's an old data, we can get it from our segment file that is sorted. That will give us O of log n time. Okay, but how data is reaching to SSTable? This is the whole concept. So whenever the data is going to be full in our memtable, we'll just simply going to run a cron, you can say, or the data is going to be flush into the SSTable. This memtable will become empty and the data is going to reach to the SSTable. And of course, durability is going to be maintained because all the queries are going to be present in write ahead logging with the help of direct IO. Now let's see how the data is stored in this segment files. So segment file is pretty simple, that the file is sorted. Let's say ABCD, BCD, CDE, and DEF. It is sorted in a order. So let's say if I have to search the word BCD in this segment file. So again, we are just going to run a simple binary search on it. Okay, in this particular file, we'll run a binary search and we'll figure it out where the BCD is present. Secondly, there are some smart algorithms that this segment file follow. In that, this segment file, what we are going to do, we can make an index over the segment file. Whenever we are going to make an index over a segment file, with the help of the B trees, we are going to make that segment. Again, the searching is going to be fast in that case. And instead of directly searching the complete data, we are going to search the exact BCD or let's say CDE document with the help of the B trees indexing that we are going to make on the segment file. Instead of complete data, we are going to make our index on our segment file. This is the first point. Second point is that is Bloom filters. A Bloom filter is known as the probabilistic data structure. I also covered in my Redis playlist that how Redis uses a Bloom filter. You can just go and you can understand what are Bloom filters. This LSM trees structure is used by the Cassandra as RocksDB, and it's used in production at very high scale. It's very good for write heavy databases. So this is all about the video. In the next video, I'm just going to cover something related to interviews, where you can just see the summary of all the indexes, and it will help you a lot for your interviews. So thank you for watching me, and bye bye.